Section 10.2 area formulas. So this is continued from the law of sines. Our objectives are to use the area formulas to find the area of triangles and to solve application problems of triangles. So recall that the area of a triangle is 1/2 times base times height. So let's say that we were given these two different triangles that we have here. So given sides A, B, and angle C, we want to find the area of the triangle. So we're given side A, side B, and angle C for each of these. So side A, side B, and angle C, given when C is greater than 90 degrees and in between 180, or if it's less than 90 degrees and greater than 0. So for this, in order to find the area of the triangle, we need to figure out what the height is. Well, how do I figure out the height given what I've known? Well, the height for this triangle over here is right here. So to find the height, we can use our trig ratios. So if I know angle C is, I can find my height. So if I look at this triangle here, by using the fact that I know what length A is, so the sine of C would be equal to h over A, because I know what the value of C is, and I also know what A is. So if I solve for the height is equal to A times the sine of C. So if my original equation is the area is equal to 1/2 base times the height, well, now we're saying that the height is equal to A times the sine of C. So I'm going to plug that into my equation to help me solve. So the area would be equal to 1/2 the base, which we're calling length B, so times the height, which is A times the sine of C. So if you notice for this equation that we have here, really, if you're given a side, angle, and a side, and it's always the included angle, you can find the area by doing 1/2 times the two sides and the sine of the given angle that you have. For example, if we want to find the area of this triangle here, then I know that the area is going to be equal to 1/2 times the sides, which is 8 times 13 times the sine of 130 degrees. So again, make sure your calculator is in degree mode. And when you plug this into your calculator, you end up with an area being equal to 39.83 centimeters, square centimeters, this area. So for this triangle that we had above, let's say that instead we were given side A, C, and angle B, then to find the area would be equal to 1/2 AC sine of B. And again, it always has to be the included angle, so we can also do that for any sides of the triangle. So that's one formula to find the area. Another formula to find the area is called Huron's formula. For this is when you're given three sides of your triangle. So given side, side, side. So if you're given three sides, then the formula is for this, you just have to memorize the square root of s times s minus a times s minus b times s minus c, and you're saying to yourself, what is that s value? Well, s is equal to 1/2 times a plus b plus c. So when you add all the numbers together and divide by 2. So for this, if we have a triangle with lengths of sides 7, 9, and 12, well, let's draw ourselves a little sketch here. So we got 12 here, 7, and maybe we'll make that one the 9. So this would be 12, 9, and 7. So if I want to find the area is equal to, first we have to find that s value, 1/2 all the sides added together, which gives me 14. And then the area would be equal to the square root of 14 times 14 minus one of your lengths times 14 minus another length, and 14 minus the third length. And all you need to do is plug this into your calculator. So this is equal to the square root of 980, which is about 31.3. And since we didn't give centimeters or units, so we'll just call this square units. And that would be define the area. So you can really use either one of the two formulas because if you know two sides and the angle in between, you could use the law of cosines to figure out what this side would be right here, and then you could use Huron's formula. Or if you know all three sides, you can use the alternate form to find an angle, and then you could use this area formula. So whatever one you prefer, it doesn't really matter. So let's go ahead and do some application problems for this. So first of all, the first problem says we have an airplane takes off from carrier B and flies in a straight line 12 kilometers. At that instant, an observer on destroyer C, located 5 kilometers from the carrier, noticed that the angle determined by the carrier, the destroyer, which is the vertex, and the plane is 37 degrees. How far is the plane from the destroyer? So for this is the vertex, and the angle that we're making, we said, was 37 degrees here. So this distance would be 5 kilometers, and this one is 12. And this is the side that we were trying to figure out, the distance between the plane from the destroyer. So for this, I know that, again, C is equal to 37 degrees. We're calling this here C, B, and A. So then C here for the length is equal to 12, and the length of A is equal to 5. So I have an angle and two sides. So since I have an angle and two sides, I know that this is the side, and angle. So this is actually a problem for the ambiguous case because we don't have the included angle. So when I'm solving this, I would want to make sure I don't have two solutions. So remember, if you want to figure out how many solutions you have, if I look at this length right here, this length is longer than this length. And remember, we said whenever this is longer than this length, then you know you're only going to have one solution. So I don't really need to solve for the second case, but you can if you want to, just to check it, but it's not going to work. So to solve this, I'm going to have to use my law of sines. The sine of 37 degrees over 12, so remember you always do this over this, equals the sine of A over 5, because we need to figure out what that angle is so we can figure out the side. So when I solve this, I get the sine of A is equal to 5 times the sine of 37 degrees over 12. Do that in your calculator. Don't forget to take the sine inverse of your answer, and you end up with A is equal to 14.5 degrees. So if I know A is 14.5 degrees, then I can figure out what angle B is by using the triangle sum theorem. So B is equal to 180 degrees minus 14.5 degrees minus 37 degrees, which is 128.5 degrees. So now that I know the angle B, I can finally solve for length B. So the sine of 37 degrees over 12 equals the sine of 128.5 degrees over B, and then I cross multiply to solve. So in this case, B is equal to 12 times the sine of 128.5 degrees divided by, in this case, the sine of 37 degrees. So B would be equal to, I'm writing out a room here, 15.6 kilometers away from the destroyer. So that's how far the plane and destroyer are away from each other. So the next problem says two surveyors are standing at points A and B, are measuring a building. The surveyor at point A is 20 feet further away from the building than the surveyor at point B. The angle of elevation to the top of the building is from point A 58 degrees, and the angle of elevation to the top of the building from point B is 72 degrees. How tall is the building? So for this problem, anytime you're not given a picture, you're going to want to draw a picture, and that's going to be usually the toughest part to do. So first of all, I have a building. And for this building, I know that the building and the ground are going to make a 90-degree angles with each other, and we want to figure out the height of the building. So we know that we have a surveyor, two of them, one at point A and one at point B. So we know that A, which is standing 20 feet further from the building than B, so this distance from here to here is 20 feet from A to B. So A has an elevation of 58 degrees from the surveyor to the top of the building. So this would be right here, 58 degrees. And then B has an angle of elevation of 72 degrees from here to here. And if I want to solve this problem, I have to think about things that I know. So for this, I need to figure out what the height is. And right now, I don't know what the height is. But I noticed that this side right here, I have this triangle here. So that is going to also correspond to, I have this triangle right here. So there's a couple of different ways you can solve this problem. I'm going to solve this using the fact that I know that this triangle and the one in the green that I drew, since I have a 90 degrees and 72 degrees, I can figure out that this angle measure right here is 18 degrees, because remember, all the angles in a triangle have to add up to 180. So if this is 18 degrees, then remember that you're going to have 90 degrees right here. But that 90 degrees doesn't help me because I don't know what this distance is right here. But I do know what this angle measure is, because remember, we can use supplementary angles. If I take 180 degrees minus 72 degrees, I know that's equal to 108 degrees. So this measure here is 108 degrees. Now if I know that, then I can figure out what this angle up here is, because again, using the triangle sum theorem. So if I figure out this little angle right here, I get 14 degrees. The reason that helps me is because I can then figure out what this common side between the two triangles is to help me figure out the height of what the building is. So in this case, I'm going to use the sine of 14 degrees over 20 feet, because I have this length right here, is equal to, I'm going to use the sine of 58 degrees over, I'm going to call this length right here A. So if I solve for A, I get A is equal to 20 times the sine of 58 degrees over the sine of 14 degrees. So A is equal to a value of 70.1. Now that I have A, I have enough information to help me solve for H in my triangle, because this is the side opposite A, so 90 degrees, sine of 90 degrees over A is equal to the sine of 72 over H. So we have the sine of 90 degrees over our A value, which we said was 70.1, equals the sine of 72 degrees over the height of the triangle. So cross multiply and solve, you get H is equal to 70.1 times the sine of 72 degrees divided by the sine of 90 degrees. So H is equal to 66.7 feet. So that's one way you could have solved this triangle. Of course, like I said before, there's other ways. And so what we're going to do in class, we're going to do some practice of the area formulas, and also we're going to do a bunch of application problems.